them because we're going to be taking little road trips, but we have to take a road trip through the mole first before we can get to the other side. Now I'm going to declare to you right now, you know the problem is going to take you 2 steps if you do not have the word mole in the problem at all. So looking up here, let's underline what's important. How many formula units are there in 47 grams? See how there's no word mole in the problem at all? When there's no word mole in there, you know it's going to take you 2 steps to get there. So, we still start off the same way. We're going to start our T-chart. We're going to put the given information, which is 47 grams, in the upper left corner, like so. Always start there. Now what's our next step? We can't go directly from grams to formula units. Where can we go from grams if we're looking at our molar mass here? What's connected to the grams? Who's in the center here? Moles. So we're going to make a pit stop at the moles first before we move on to formula units. Formula units is over here in the representative particle category. So I diagonal down my G just like I would before. Going to put moles up here on the top. Remember, everything always equals 1 mole. I'm going to continue on. I'll do my molar mass in just a minute. I can go from moles now to what? I can go from moles to formula units. I could also go from moles up to liters if I wanted to. But in this case, it doesn't want liters. It wants formula units, which is a type of particle. So now, I diagonal down the mole. This mole now goes down here, right? 1 mole equals how many formula units? What's the magic number for particles? Avogadro's number, 6.02 times 10 to the 23rd. Good. So now that I have the general setup, I can calculate my molar mass for FeF3. That's iron 3 fluoride. So let's go over here and calculate that. What is the mass of iron? Put that up on the table. It's going to be what? 55.85. Remember, round to the hundredths, which is 2 place values to the right. This is your hundredths place values. There's only 1 of those, 1 iron. But our fluorines, how many of them are there? We have how many? 3. So we're going to multiply the fluorine number by 3. And what's fluorine's mass? So the 18.999 is going to change into 19.00. So that one will be 19.00. So that gives us a mass of 57.00. So we can add these two together now. The 55.85 plus the 57, what is the mass of that equal? 112.85. Notice all of these are going to the hundredths here, the second place value to the right there. So now I can insert that value up here. 112.85 next to the grams where it's supposed to go in the T-chart. Okay, so just to remember what the T-chart tells us. The T-chart tells us to multiply everything on the top, multiply everything on the bottom, and then divide. So technically what this represents would be 47 times 1 times 6.02 times 10 to the 23rd up top, divided by 112.85 times 1 on the bottom. Now you can take the ones out because obviously they're not going to do a whole lot. When you're punching in the calculator too, you should just do it in one series of steps. So take your 47, punch it in, multiply it by your 6.02 times 10 to the 23rd, then hit enter, and then do divided by your 112.85. Do it all in one big grouping there to get your answer. Now we're getting the calculator answer here. What was the calculated answer going to be? Anyone? Anyone? Okay, so that sounds right, except for it's 2.5072 times 10 to the what? 23. Good. Now we have to stop and look at sig figs from the beginning. So over here, how many sig figs in our beginning number? Only 2. So guess what? We only get to keep 2 in our answer. Remember, you always start from the left. So we're going to keep this 2. Now we're going to look at this 5. Do we round up the 5 or do we leave it alone? Because the 0 is next to it, we would round it down and leave it alone. So it'd be 2.5 times 10 to the 23rd, formula units of FEF3, and we would circle this as our final answer. Yes, that one took a little extra because we had to do the molar mass and things in it. Now also, if you look up here, just to check our work, do the grams cancel with the grams? Yes, grams over grams equals 1 basically, so cancels. And then does the moles cancel with the moles? Moles cancels with the moles, moles over moles. So what are we left with? Just formula units, which is what we want as our unit. Okay, now let's try number 2. Let's go set that one up together. And then I'll let you try to set a couple up on your own. So number 2, let's look at what we want. It says how many liters at STP are there in 400.3 grams of O2? So this one involves grams and this one involves liters. So if we look at our molar, our map over here, we're going to go mass to moles, moles to liters. So it's going to take 2 steps. So given information in the upper left corner, who goes there? What should I put up there? The 400.3 grams. That's exactly right here. Okay, now what do I need to do with that G? Diagonal it down. Good, because we want to get rid of it. Grams can go to what, though, on the mole map? What's in the middle? Can go to moles. Good. Everything always equals 1 mole, right? Now, keep going because we want to get to liters. Now that I'm at moles, what can I do with my moles? I can go from moles up to liters. So I'm going to do what with my moles here? Diagonal them down, right? They're going to go down here. Diagonal them down. And everything equals 1 mole on the map, right? So we always put the 1 next to the mole. Now, what is the magic number for liters at SPP? It is 22.4. So we need to memorize that number, 22.4 liters, right? We only have to do one little thing. I always wait to do the mass at the end because that's going to be, take an extra step. We need to calculate the molar mass of oxygen. What's oxygen's mass? 2 times 16.00, right? Because it's 15.998 something, so we round it to 16. So this is going to be 32.00 is our mass. Okay? So yes, so the 32.00 would go there. Now, just like before up above, we're going to multiply everything on the top. We're going to multiply everything on the bottom, and then we're going to divide. We're going to do it all in one step. So, punch in your calculator. 400.3 times the 22.4 Hit enter, and then do divided by 32. And that should give you your answer. Remember, the ones, we can kind of not calculate them in because everything times 1 is itself. So, we get 280.21. Now I have to look at my sig figs. How many do I start with over here? 1, 2, 3, 4. Good. So how many do I keep? Only 4, starting from the left. 1, 2, 3, 4. Do I round up the 2 or leave it at a 2? This is a 1 next to it, so I'm going to leave it at 2, so it's going to be 280.2 liters O2. Okay? And if you look again, just to check, moles cancel with moles, right? Grams cancel with grams, and what am I left with? Liters, which is what I want. So right now I'd like you to try 3 and 4 on your own, and then we will go over those answers together. So attempt trying to set them up, work with your table mate. So just check your answer, solving these, look for your sig figs, look for your labelings, make sure you labeled correctly. Check that answer real quick. Okay. Everybody do okay on 3 and 4? All right, let's look at real quick. On the back, I want to go down, excuse me, on the back, I want to look at number 6. Now, number 6 is not going to be one that you're expected to do on the quiz. It may be like a bonus, though. So some of you that might want to challenge might want to look at it. All it really takes is one little extra step to it. So, how many atoms of O are present in 78.1 grams of oxygen? So you won't be expected to do one of these on the test or anything, but I wanted to show it to you for those that want a little bit more of a reach here. Just has one little added extra step. We still start with our 78.1 grams that go in the upper left corner. Now we're going to diagonal down our grams and we're going to go to moles. But we have O2 here. O2 is not an atom. O2 is actually a type of molecule because it's covalently bonded. So I'm going to work it to molecules first. We're going to go to molecules first. So I'm going to diagonal down my 1 mole, and I'm going to go through 6.02 times 10 to the 23 molecules. Okay? Now this is where the added extra step goes. If you look at O2, how many atoms of oxygen are in a molecule of O2? How many actual atoms are in O2? 2, right? Okay, so far so good. So we could add on one little added extra step where we put one molecule equals 2 atoms of O, right? So the only thing left to do is insert our molar mass of oxygen. We already know this, right? What's the molar mass of oxygen? It's 2 times 16.00. So that equals 32 grams. So we would put that in here. Okay. So now you can multiply the top, divide by 32, and you can get the number of atoms in O2. Basically, you find the molecules and multiply it by 2. That's all you'd have to do with the added extra little step there. If you wanted to do that, like I said, this would be more like a bonus question. But I wanted to work it for you so that you had the answer over here. So I'm getting 2.9385 times 10 to the 24th. And we keep 3 sig figs, 1, 2, 3. 1, 2, 3. So I'm going to round up that 3 to a 4. 2.94 times 10 to the 24. Now it's atoms. O, just atoms of oxygen. Okay? So like I said, if you're interested and want to go that extra step further, really it's not that hard, but as you can see, we would call this one a 3-stepper because it takes 3 steps to complete. Okay?